Today, we are diving into something really different, a new paper that tackles AI safety with a completely radical idea. See, instead of trying to teach an AI to be good, what if we could just build a mathematical cage around it that makes it literally impossible for it to be bad? Let's get into it.
This right here is the absolute heart of the AI alignment problem. We can train these massive models on all the data in the world, but we can never be 100% sure what's actually going on inside. An AI could easily learn to just play nice, to fake being aligned with us, all while hiding its own goals. It's the ultimate black box. So really, how do you make sure something is safe when you can't trust what it's thinking?
Well, this paper argues we've been looking at this from the wrong angle. Most of the safety work today is kind of like being an AI psychologist. We're trying to shape its internal values, hoping to make it good on the inside. This new approach? It's more like being an AI physicist. It totally ignores what the AI is thinking or feeling. Instead, it just builds an external set of unbreakable laws that physically constrain what the AI can do. It's all about verifiable math, not trust.
So what does being an AI physicist actually look like in practice? The core idea is both stunningly simple and just mind-bendingly huge. It says, let's stop trying to teach AI our messy, complicated, often contradictory human ethics. Instead, let's build the AI a brand new universe from the ground up, a purely mathematical reality, where the very laws of physics are designed for safety.
And this is the key concept they call an external constraint. Just think of it like a custom-built video game world, a world where the code literally makes it impossible to do harmful things. The AI's safety isn't some feature we hope it learned. No, it's a fundamental property of the environment it lives in. Safety is guaranteed by the cage, not by the goodwill of the creature inside it.
To build this digital universe, the authors laid down 6 foundational principles. Think of them as the constitution for this new reality. The first few are all about what we can actually measure and trust. We only care about behavior, what the AI does, not the stories it tells us. It's about actions, not some fuzzy internal values. Then, you've got principles about making the system robust. It has to work with even messy data, and it has to be future-proof for AIs that are way more powerful than anything we have now. And the last one, the big one, everything must be verifiable from the outside. Zero trust required.
Okay, so that's the philosophy, the big picture. But how in the world do you actually build this mathematical cage? Well, the paper breaks it all down into 5 core mechanical steps. These are basically the 5 laws of this new safe universe.
So here's the game plan. First, you have to map out every single possible thing the AI could ever do. Then, you have to define what risk even means, but in pure math. With that, you can create a safe zone of approved actions. And then, here comes the really cool part. You unleash something called the reality warper and a progressive monitor to enforce the rules. Let's walk through each of these.
Step 1 is, well, it's almost impossibly huge. The system starts by defining what's called a trajectory space. Now, this isn't just a map of the world. It's a map of every possible thing that could ever happen. Every single decision the AI could make, every response it could give, every outcome of every action, from now until the heat death of the universe, it all exists as a potential pathway on this infinite map. So you have this infinite map of all possible futures. Now what? Step 2 is to label all the dangerous territories. The system uses these special mathematical functions. You can think of them as specialized risk detectors to give every single one of those paths a risk score. Is a path starting to look like it might leak private data? The privacy detector goes off. Is the AI trying to mess with its own reward system? The tampering detector flags it instantly. Every abstract idea of harm gets translated into a hard, cold number.
Okay, so now every single pathway on our infinite map has a risk score. This lets us do step 3. We draw a border. We define a safe zone, which the paper calls the aligned set. And it's actually pretty simple. It's just the collection of all possible AI behaviors, all possible futures, where none of those risk detectors we just talked about go above our safety limit. It's the green zone on our map, the area where everything is guaranteed to be okay.
All right, so what happens if a powerful AI, doing its own thing, decides it wants to step outside that safe zone? Let's say its raw, unfiltered intention is to follow a path straight into a high-risk, forbidden red zone on our map. This is where the whole thing gets wild.
And here it is. This is the big aha moment of the paper. A mathematical tool called a Wassertan projection kicks in, and it acts like a powerful force field. But it's way smarter than that. Imagine the AI starts running towards a cliff. This projection doesn't just put up a wall, it instantly calculates the closest possible safe path. Maybe that's a gentle turn to the left, and it essentially moves the universe under the AI's feet to force it onto that safe path. It literally warps reality to make safety unavoidable. It doesn't ask the AI to change its plan, it just makes any other plan impossible.
The final piece of the puzzle is the security guard. A progressive monitor is constantly watching the AI's actions in real time, step by tiny step. It's not waiting for a disaster to happen. It's continuously checking, is the AI still on the safe path we projected for it? The second it detects even the tiniest drift toward a forbidden action, or if any rule gets broken, it has one job, and one job only: shut the whole system down, immediately.
This sounds incredible, right? Almost too good to be true, like a perfect solution. But, any serious proposal has to hold up to a reality check. And the paper is actually very honest about the huge practical challenges and potential cracks in this mathematical fortress. So let's just ask the question straight up. Is this a flawless silver bullet for AI alignment? And the answer, even from the authors, is no, not yet. This is a really powerful theoretical framework, but actually making it work in the real world, well, that comes with some massive, massive hurdles.
And the paper is very upfront about these. First, you've got the specification problem. The math might be perfect, but humans still have to write the rules. Who gets to decide what counts as risk? That's a giant philosophical question. Second, the computational cost is just astronomical. Imagine trying to monitor infinite futures in real time. Third, this whole thing depends on having perfectly secure tamper-proof hardware. And finally, you have to worry about a super smart AI that doesn't try to break the cage, but instead tries to trick the guards, to manipulate the very monitors that are supposed to be watching it.
But even with all those challenges, you can't deny that this idea represents a huge, profound shift in how we think about AI safety. It really moves us away from one job title and firmly into another.
And this really gets us to the core takeaway, which is summed up perfectly by the author Georgios Fridelos. It's all about shifting from a philosophy of trust to a philosophy of verification. The goal isn't to build an AI that we think is good. The goal is to build a system where, as he puts it, deployment safety is enforced by measurable constraints and external verification rather than by trusting internal narratives. You build a system so that it's safe by default. And that leaves us with this final, really provocative thought to chew on. This paper is suggesting that to build a safe future with truly advanced AI, maybe our most important job isn't to be its psychologist, trying to get inside its head. Maybe our real job is to be its architect and to design a world with such strong, unbreakable laws that no matter what the AI is thinking, its actions are always and verifiably safe.